Hey everyone, welcome back, and today let's solve Leetcode problem 3105 titled Longest Strictly Increasing or Strictly Decreasing Subarray. So we're given an array of integers nums, and we need to simply return the length of the longest subarray of nums, which is either strictly increasing or it's strictly decreasing. Now they do give us definitions for all three of these vocab terms, but to kind of summarize what they really mean, you guys probably do know what a subarray is. Effectively, it's basically just one portion of a contiguous block of integers in a data structure. In this case, it'll be an array because it is a subarray. And what a strictly increasing subarray is, basically, it's an array that where every single element is strictly greater than, meaning it's not greater than or equal to, but just greater than the previous element. So, for example, if we had an array like 1, 2, 3, this would be strictly increasing because every single element is greater than the element before it. But something like 1, 2, 2, 3 would not be strictly increasing because 2 is equal to 2. We can't have any elements be equal or less than the previous element. We have to have them be greater than their adjacent previous element, right? And very similar definition structure, what a strictly decreasing subsequence is. Basically, it's the same exact thing, but in reverse order, meaning it's going to be something like 3, 2, 1. Every single element is going to be greater than the element after it, or every single element is going to be less than or equal to the, or rather not equal to, but rather less than the element before it. So for example, 3 is greater than 2. If they're both equal, it would not be strictly increasing, or it would not be strictly decreasing. It would simply be nothing. It'd be plain. But since 3 is actually greater than 2, and 2 is actually greater than 1, it would be strictly decreasing. If we added a 2 here, it then wouldn't be strictly decreasing because 2 is equal to 2, and they are actually adjacent to each other, right? So in example 1, we have our input array nums to be 1, 4, 3, 3, 2. Now note that the entire input does not necessarily have to be either strictly increasing or strictly decreasing. We just want the longest subarray or contiguous portion of this input that follows either one of these strictly increasing or decreasing rules. And we have to actually output the maximum value out of any of those subarrays, right? Again, it doesn't matter if our subarray that we choose with the maximal length, if it's either strictly increasing or if it's either strictly decreasing. It just has to be one of those two properties, and its length has to be maximized. So in this case, in example 1, we actually have an output of 2. Now, although our output is 2, we actually have multiple different subarrays that either are strictly increasing or decreasing. And an important thing to note is that worst case, any subarray can be strictly decreasing or increasing because it would just be that element itself. And so 1, 2, 3, 4, 1, 4, 3, 3, and 2, they're all strictly increasing and strictly decreasing by themselves, right? Each element by themselves have both of those properties. Now, in terms of the strictly increasing subarrays, we have all those, and we also have 1, 4, this contiguous portion of the array. Why? Because 1 is less than 4, 4 is strictly greater than 1, and there isn't any more elements that we can add to that subarray to keep it strictly increasing. And for the extra strictly decreasing subarrays, we also have 3, 2, and we also have 4, 3. Now note that all of those subarrays are either length 1 or length 2 that are all either strictly increasing or strictly decreasing. And in this case, since we want to maximize our length, we'd simply have an output of 2, right? Because the maximal length of either a strictly increasing or any strictly increasing or strictly decreasing subarray would be 2. In example 2, we have our input array nums to be 3, 3, 3, 3. A little bit of a special case here. In this case, our output has to be 1 because every single element is equal to each other, and we know that strictly increasing or decreasing subarrays are defined to be elements that are not equal to any adjacent elements. They have to be either strictly less than or strictly more than their adjacent previous values. And so if we have an input array nums where every single element is equal, we have to have an output of 1 because we know that any subarray by itself or any element by itself is guaranteed to have a is guaranteed to be strictly increasing or strictly decreasing. Something important to note, right? So in this case, we have to have an output of 1. And finally, for example 3, we have our input array nums to be 3, 2, 1. Now, there isn't a single subarray in this case that's greater than length 1 that is strictly increasing. But if you look at it, the entire subarray itself is actually strictly decreasing, right? 3, 2, 1, every single element is less than the element before it, right? 2 is less than 3 and 1 is less than 2. Every element is greater than the element after it. And so this is strictly decreasing. the maximal length of all the decreasing subarrays, either 3 to 1, 3 2 2 1, or 3 2 1, is 3. And so our output is going to be 3. So for the constraints here, we see that the length of our input array nums is not going to exceed 50, and any element value or element integer in our input array is not going to exceed 50 either. That's why it isn't really too bad of a problem. We do have pretty small constraints as well. We don't have to have the most efficient of solutions, but regardless, we're basically going to have, spoiler alert, a pretty straightforward linear implementation for the solution of this problem. So how can we really solve this problem efficiently? Like, what is a good way to go about it? Well, let's think about it. We really only have two choices for a current subarray to be as we traverse through the array. Either it can be a strictly increasing array, or either it can be a strictly decreasing array. So what does that really mean for in context of our solution? Well, effectively, that really means is to really solve this problem efficiently, which really we don't have to really worry about too much because of our relatively small constraints as such. Really, we only need a single pass traversal of the array, or a single pass solution, right? And in that singular pass or traversal, or I should say for loop of the data structure or our input, basically we're also going to be maintaining counters for both the lengths of the current increasing subarray and the length of the decreasing subarray. And effectively, in each iteration, we maximize the length of those two property subarrays, or those two values, to get the maximum possible length of a subarray that is either fully strictly increasing or fully strictly decreasing in the input array at any given point in time or at any iteration. So how is our algorithm actually going to look on a high level? Effectively, again, we're going to first initialize three variables: max length, incremental length, and decreasing length, right? Pretty self-explanatory. Max length is going to be our return variable to actually keep track of the maximum length of the subarray that's either fully strictly increasing or decreasing. And increasing length and decreasing length are basically the length of the current increasing and decreasing subarrays. And for the actual traversal here, we're actually going to iterate through the array starting from the second element. And now why is that? Well, let's think about it. We know for sure that the current element depends on the previous element, whether it's less than or greater than the previous element. Now, the first element doesn't have a previous element, so you can think of it as like the independent element, right? All the elements depend on the element before them, but this one doesn't have an element before. And to kind of reiterate what that really means, the reason why elements depend on the element before is that an element depends on the element before it, because if it's greater than it, we know we're currently at a strictly increasing subarray. But if it's less than the element before it, we know we're forming a strictly decreasing subarray. Very important to note for in context of this problem, right? That's why we actually start iterating from the second element and onwards. And basically, for each element, we first check, is it greater than the previous element? And if that's the case, of course, we can increment the increasing length for the current subarray, because it is, of course, an increasing subarray, or we decrease, or rather, we have to actually reset the decreasing length subarray to be 1, because we stopped forming a decreasing subarray. We're now currently building an strictly increasing subarray, and so we don't have a decreasing subarray that's greater than or equal to the length of 1. However, pretty similar logic. If the current element is less than the previous element, then we're forming a decreasing length subarray, and so we have to increment the decreasing length and reset the incrementing length to be 1, meaning we're not currently on an increasing length anymore. The only increasing subarray we have at this iteration is simply the element itself that we're currently visiting, and so the decreasing length subarray now increases in size because the current element is actually less than the previous element, meaning we're actually forming a decreasing subarray with the two elements in the current iteration, right? However, the final thing we have to actually check is, what if the current element is actually equal to the previous element? In that case, we have to reset both the increasing length and the decreasing length to be 1, because we know that in strictly increasing or decreasing subarrays, no elements can be equal to each other, because that kind of makes the strictly part quite redundant, right? And effectively, in each iteration, as we actually increment the increasing and decreasing length subarrays accordingly, we have to actually update or maximize our maximum length with the maximum value amongst, of course, itself, because we don't want to make it smaller, and the increasing and decreasing length, whichever one is larger at that given specific iteration, based on the length of our current increasing and decreasing subarrays. And effectively, once that single pass or for loop completes, after we actually finish the traversal, the maximum length will be a return value, which is again going to be the length of the longest subarray that is either fully strictly increasing or fully strictly decreasing, and that is effectively what we're going to return at the end of our solution. So with the high level rundown out of the way, let's go ahead and dive straight into the code here. So like I talked about just now, what I'm first going to do is actually initialize my three variables, max, length, and increasing and decreasing length. So the way I can do that in Python, pretty straightforward here. This is, of course, going to be initialized to 1. Now, the reason why it's not going to be initialized to 0 is because we know, guaranteed, for any input array, regardless of its elements, the maximum length has to be at least 1. Because any element by itself, or any subarray with a singular element, is guaranteed to either be both strictly increasing or strictly decreasing, because there's really only one element to it. Right? The smallest possible subarray that we can even form has to have at least one element. So we can't get smaller than a maximum length of 1. Now let's actually increase or initialize our increasing and decreasing length integers. So I'm just literally going to call them increasing length and decreasing length, a neat way to do it in Python. And they're both going to be initialized to 1 as well. Very similar explanation there. They both have to start at 1 because, of course, a single element would already be an increasing subarray of length 1, and also an increasing, or rather a decreasing subarray of length 1 by itself as well. Increasing length, again, would simply keep track of the current strictly increasing subarray at that given iteration, and the decreasing length would keep track of the current strictly decreasing subarray length at that given iteration as we actually input, or rather iterate through our input array nums. Okay, well, once we actually initialize these three variables, let's begin the main part of a solution, the one-pass solution with a singular for loop, iterating through each element once. So, for I in the range of the length of our input array nums, now keep in mind we have to start from the second element. In this case, it's the first index because data structures are always going to be 0 indexed for the most part in programming, and going up until the length of our input array nums for all the other elements that we have in our input. Right, we're starting from index 1 because we have to actually compare nums at I with nums at I minus 1. We can't compare nums at 0 with nums at 0 minus 1 because then we would get a negative index or an index out of bounds, which would actually break our code. Okay, well, in every single iteration of this for loop, what if the current element is greater than the previous one? We know we have a strictly increasing subarray in that case. So the way we can check that is if nums at the current index I, if it's greater than nums at the previous element, I minus 1, basically index I minus 1, that means the current element is greater than the previous one. And if that's the case, we know that our current array with these two elements is going to be strictly increasing. And so we have to actually increment the current increasing length of our current increasing subarray by 1. So I just increment that variable plus equals 1. Because that actually signifies that we're increasing the length of the current increasing subarray, that is strictly increasing subarray, by 1 because the current element actually forms or kind of adds on to that increasing subarray because it's greater than the previous element. And once we actually do that, we then have to actually reset our decreasing subarray length to then be 1 because we know that our current decreasing subsequence, or rather subarray, it's kind of interrupted. We stop forming it, the current element is no longer less than the previous element, it's now greater than it, meaning we're actually forming an increasing subarray from this element and onwards instead of a decreasing one. So we have to actually reset it to 1 because the length of the current decreasing subsequence or subarray is now simply going to be that single element itself, nums at index I, right? Great. But what if nums at I is less than nums at I minus 1? Well, very similar logic there, but that simply means that the current element is less than the previous one. And that means that our current array with this element is now strictly decreasing. And so very similar logic, we actually have to increment the decreasing length subarray in the current iteration by 1 because we're adding on the current element nums at index I to that input array, or that current decreasing subsequence, because of course we're actually increasing the length of the current decreasing subarray by 1 because we found a new element that actually finds that property of being less than the previous element. And of course we have to then reset our increasing length subarray to then be 1. Why? Because the increasing subarray is now interrupted by the decreasing subarray. Now the only increasing subarray length that we have in this iteration is simply the current element by itself. And eventually, once we're done, if both of these two conditionals don't execute in the current iteration, that means in the else conditional here, that both of the elements are equal. That means nums at index I is equal to the previous element, nums at index I minus 1. And that means, like we talked about before, the sequence is neither increasing nor is it strictly decreasing. Because, of course, that would make the strictly keyword here completely redundant. So if this is the case, we know we have to then reset both our increasing length and our decreasing length subarrays to then be 1. Because, of course, the current element doesn't form any of these two properties. The entire sequence has been broken regardless if it's increasing or strictly decreasing, because of course we can't have elements be equal in either strictly increasing or strictly decreasing subarrays, because that kind of makes the strictly part redundant. Now, once we actually finish these three conditionals at each iteration, we want to get the maximum length and maximize it to be either itself, if itself is greater than the current element, or the increasing length, or the decreasing length. Right? Of course, basically it would be the largest value among the current values of the maximum length, increasing length, and decreasing length. Basically, the current value of maximum length and the current lengths of the current increasing subarray length and the current decreasing subarray length. And effectively, in each iteration, once we actually maximize this for all of the lengths of all of the increasing and decreasing subarrays for every single input array that we can actually form, subarray that is, in our input array, we simply have to return the maximum length as our return variable once it's actually done executing, because that would be the length of the longest strictly increasing or strictly decreasing subarray in our input array nums. So unless I made any syntax errors here, this should be accepted and there should be a valid solution. Okay, let's see what I did wrong here. Probably a quick syntax error on my part, to be completely honest with you guys. Let's just double check I didn't do anything dumb. Range 1. Did I -1? And feel free to just fast forward this part. This is just me having very, very dumb syntax errors here, or logic errors. Yeah. So, of course, I forgot the elif. This can't be a whole separate else, or this can't be a whole separate if statement. It actually does have to be connected with this if statement above, because otherwise then this else would be redundant, and we don't want that. And so, yeah, now this should be accepted, and now this should actually work. Let's just go ahead and double check it works. And as you can see, this really is just about as efficient as you can really get. So to kind of reiterate what the code actually does as a whole and how it really works entirely, again, we're simply traversing our input array with a single loop or a single pass here, and effectively in each iteration that we're actually doing this iteration, basically we're tracking the current increasing and decreasing subarrays using the two counters, increasing length and decreasing lengths, with their corresponding lengths based on whether the current element is either less than or greater than the previous element. And effectively we're simply updating the maximum length dynamically to always make sure that we always get the longest valid subarray that's either fully strictly increasing or strictly decreasing at any iteration in the input array. And effectively, once the for loop actually is done executing, we simply return the final answer in maximum length. So for the time complexity here, pretty straightforward. It's simply a linear big O of n solution. Of course, we're really traversing the array only once with a single loop here. We're basically performing constant time operations inside the for loop here, big O of 1 basically, and every element in the input array is visited exactly once with the singular for loop here. And for the space complexity, we actually only use 3 integer variables: max length, increasing length, and decreasing length. And all of these variables do not actually scale with the input size, and so it is going to be a constant time memory or space complexity and a big O of 1 solution for that. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.